5. Lesson 5. Eric, don't make me come back there. I'll beat you like your soccer team got beat.
As well as Canada.
Yes, they did. Ask me if I really care deep down. I don't. Okay, so remember what our three trig ratios are: the sine, cosine, and tangent. SOHCAHTOA tells us what they are. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And so I've said before that surveyors use trigonometry all the time in their work. So we'll see some examples of how they might use trigonometry to solve a problem. In this case, a surveyor wants to determine the width of the river for a proposed bridge. The distance from the surveyor to the proposed bridge site is 400 meters. So that's that number right there. So you see he's walked 400 meters away from where the bridge will start. He uses this device called a theodolite to measure the angles. And he finds that the angle from where he is to the other side of the river is 31 degrees. What is the width of the river? So we want to find out what the width of the river is, which let's say is W for width. So this is an example of where a surveyor might use trigonometry to solve a problem. So like we did before, we would start by labeling the sides of the triangle. The side across from the right angle is the hypotenuse. This 31-degree angle is given. We're going to use that. The side across from that is the opposite. The third side is the adjacent side. Then, in this case, we want to find W, which is the opposite. We're given 400, which is the adjacent. We're going to use opposite and adjacent. We're not given the hypotenuse, not going to use it. So Jet, what ratio uses opposite and adjacent? And what does the TOA mean? Tangent. So to write the equation, the tangent of the angle, which is 31 degrees, and the order matters. The TOA part tells us that it's O first, A second. Opposite on top, adjacent on the bottom. It must be W over 400. We make both sides a fraction so we can cross multiply. 1 times W will equal 400 times the tangent of 31 degrees. When you cross multiply, that's what you get. Okay, Mason, are you with us? So we go to our calculator. And the calculator has to be in degree mode, which mine is. So now I can go 400 times tan of 31 degrees, and we have our answer. 240 to the nearest meter would be 240 meters. That's how wide that bridge site is, where the bridge is going to go. 240 meters wide. You have the trig book, Lindsay? Pardon? After we're done the notes, yeah. Okay, so there's that one. Next one, a pilot starts his takeoff and climbs steadily at an angle of 12.2 degrees. Determine the horizontal distance, which is what x is, that the plane travels when it has climbed 5.4 kilometers along its flight path, and also the height of the plane at this time. So we want to find both x and h to the nearest tenth of a kilometer. So let's say we want to find x first. So we're going to start by labeling the sides of the triangle. The side across from the right angle is the hypotenuse. The side across from the angle that we're given is the opposite. The third side is the adjacent side. So this part, it doesn't matter what you're trying to find first. It doesn't matter how you label the sides. That's never going to change. But what will change is which sides you circle. If we want to find x first, x is the adjacent side. You're given the 5.4, which is the hypotenuse. So we're going to use adjacent and hypotenuse. What ratio is that, Sydney? Cosine, that's right. The ca part tells us that cosine uses adjacent and hypotenuse. So the cosine of the angle, which is 12.2 degrees, equals, and the order matters. The ca part tells us it's adjacent first, hypotenuse second. Adjacent on top, hypotenuse on the bottom. Make both sides a fraction so we can cross multiply. 1 times x is x, and that equals 5.4 times the cosine of 12.2 degrees, which we'll get from our calculator. 5.4 times the cosine of 12.2. To the nearest tenth, that would be 5.3 kilometers. Which is a reasonable answer. Remember, the hypotenuse is always the longest side, and 5.4 is bigger than 5.3, just. The reason they're so close is because the angle, 12.2, is quite small. The bigger that angle would be, the greater x would become. Okay, so there's the answer for x. But we also want to find h, the height of the aircraft, which we can use a trig ratio if we want, or we can use Pythagorean theorem. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the two legs of the triangle. The legs are the two sides that are perpendicular to each other. The hypotenuse has to be c. So if we say that a is the 5.3 that we just found, and b is the height, those are the two legs of the triangle, that must equal the length of the hypotenuse squared. Now, just to make this a little easier, making fewer calculations, I'm just going to subtract 5.3 squared from both sides right here. So on the left, the 5.3 squareds will cancel, and you have h squared by itself. So on the right, I need to use my calculator to go 5.4 squared. And to be as accurate as possible here, instead of just typing in the 5.3, which was the rounded value from the previous answer, I'm going to use the previous answer. This calculator has the ability to do that. If yours doesn't, then you just want to type in as many decimals as you can. 5.278045829. Type them all in. That'll give you the most accurate answer. So h squared is 1.30223. 1.30223, and there's more numbers. I'm just not going to write them all down. To find out what h is, then we take the square root of both sides. Square root and square will cancel each other out. And so we'll have our answer for h by taking the square root of this number that's in the calculator. So 1.1 is the approximate answer. 1.1 kilometers is approximately how high the aircraft is. We could have used a trig ratio to find that number as well. I just chose to use Pythagorean theorem. If you've got two sides of a right triangle, you can find the third by using Pythagorean theorem. But I could have used a trig ratio. If I wanted to use the opposite and hypotenuse, I could have done that by using the sine ratio. It would have worked. Okay. Example 3, a ladder leaning against the wall forms an angle of 63 degrees with the ground. So we're going to draw a right triangle. Right? You can only use Pythagorean theorem and SOHCAHTOA if you have a right triangle. Sometimes the diagrams are given to us, sometimes we've got to draw our diagram. So in this case, we have to make an assumption that the ground and the wall are perpendicular to each other. They form a right angle. So the ladder is the hypotenuse. It's leaning against the wall, and it makes an angle of 63 degrees with the ground. So that's at the bottom. The ground is at the bottom. How far from the wall to the nearest meter is the foot of the ladder? So that's x, the distance from the bottom of the ladder to the wall, if it reaches 4 meters up the wall. So that's the height of this triangle. That's how high up the wall the ladder reaches. We want to calculate the length of the ladder, so we'll call that L, the length. How long is the ladder? Label the sides. Side across from the right angle is the hypotenuse. We're given that 63-degree angle. Side across from that's the opposite. Third side is the adjacent side. So there's two answers that we want to find. First, we want to find how far from the wall to the nearest meter is the foot of the ladder. We want to find out what x is. So if we're going to find x, based on what we're given that opposite side to be 4. X is the adjacent. The ratio that uses opposite and adjacent is the tangent ratio. So the tangent of the angle, which is 63 degrees, equals, and the order matters. The total part tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. Make both sides a fraction, and then cross multiply. In this case, when we cross multiply, it doesn't matter which pair you start with first. I'm going to start with the pair that has x. It's x times tan of 63 equals 1 times 4. This is one of those ones that we looked at before where we have to do an extra step to get x by itself. We're going to have to divide both sides by tan of 63 degrees to get x by itself. And so our calculator will tell us what x, the distance that the base of the ladder is from the wall, is by dividing 4 by the tan of 63. So 2.03 to the nearest tenth, approximately 2 meters. So now we have two sides of the right triangle. Right, this was part A, finding the distance that the base of the ladder is from the wall. Part B is finding the length of the ladder. And because we have two sides, we can use Pythagorean theorem if we want. We could also use a trig ratio, but I'm going to use Pythagorean theorem. I've got the two legs of the triangle now. The height was 4. The base was 2 meters. That was a rounded number. Those are the two legs of the triangle. We want to find C, the hypotenuse, and I guess instead of C, why don't we say L, because that's what we labeled it as. So on the left side, we'll have 4 squared plus, and again, it's always best to use the entire number in your calculator. So I can go second function negative on this calculator to get the previous answer. If you don't have that on yours, type in all those decimals. 2.0381011798 squared. Type them all in. It'll give you the most accurate answer. So L squared will be 20.15 approximately. And then to find out what L is, we take the square root of both sides. The square root of 20.15. approximately 4.5, if we round to the nearest tenth, is how long the ladder is, 4.5 meters. Okay, so we found how far away from the base of the ladder the wall is, as well as how long the ladder is. Walter drives a logging truck for a paper mill near Corner Brook, Newfoundland. The sign is posted on the hauling road that leads from the mill to the logging site to warn truck drivers of a very steep slope. The slope of the hauling road that Walter uses makes a 5-degree angle with the ground. The mill and the logging site are 2,216 meters apart horizontally. Draw a diagram for this scenario. Determine how high the logging site is above the mill, and also determine the length of the road correct to the nearest tenth of a meter. So again, we can start by drawing a right triangle. It's not going to be a very high triangle though, because the road makes an angle of 5 degrees with the ground. So that's a very small angle, 5 degrees. We're told that the mill and the logging site are 2,216 meters apart horizontally. So that'll be at the bottom. Part A says, draw the diagram of the scenario, determine how high the logging site is above the mill. So that means the mill is lower than the logging site. We can label this other corner whatever we want. Let's just put an X there. So we want to know how high the logging site is above the mill. So we want to find H, the height of this rectangle. So even though it's true that this site isn't directly above the mill, S is directly above X, but X is the same height. It's on the same level as M. So H, not only does it show us how high above AX S is, it also is how high above H, or excuse me, how high above M. Also determine the length of the road, which would be that side there. That would be the hypotenuse of the triangle. So those are the two things that we're trying to find. But we have to start by using a trig ratio. We cannot use Pythagorean theorem right now because we only have one side. So if I want to find H first, I start by labeling the sides of the triangle. Side across from the right angle is the hypotenuse. We're given the angle of 5 degrees, we're going to use that. The side across from that is the opposite. The third side is the adjacent side. And again, if I want to find H first, I'm going to use the opposite and the adjacent, which is the tangent ratio. The tangent of the angle, which is 5 degrees, equals the opposite, H, over the adjacent, 2216. So once again, we make both sides a fraction, and we cross multiply. So H will be 2216 times the tangent of 5 degrees. So that's approximately 193.9 if I round to the nearest tenth. 193.9. And now, because I have H, 193.9, that's one of the legs of the right triangle. I have the other leg of the right triangle as well. I can find the third side of the triangle. I can find the hypotenuse L using Pythagorean theorem. So this is answering part B. So the two legs are A and B. It doesn't matter which one is A, which one is B. Just have to make sure that I Make C the hypotenuse, which in this case is L, the length of the road. And once again, I rounded the 193.9 off in my calculator, but I'm going to use the entire number in my next calculation. 2216 squared plus the previous answer squared. And if you don't have that function, don't know how to use it, type in all the decimals. 193.8748784 squared. Gives us a really big number for L squared. 4,948,243. 4,948,243. 0.468. That's what L squared is. So to find L, I take the square root of both sides. So the square root of that big number, 224.5 approximately. Oh, sorry, 2,224.5 meters is the approximate length of that road. Okay, so we'll stop there. I got some questions for you to work on. I will post these solutions to Google Classroom so you can check your answers. Do the practice, it's important. Some of you did not do great on that quiz, and it's because you didn't do all the practice. Got to do the practice. Yeah, make sure you sign out, please.